Okay, here we go. All right, this is in your SOL. This is in the SOL, number 18. Pretty good. There's that. And, okay, so number 18. This is absolute value less than. We're responsible for absolute value equations and inequalities. And for inequalities, they could be less than or they could be greater than. Okay, so we're going to solve this with the math. Then what's the first step of solving any of those three? Isolate, right? So you always have to isolate the absolute value. This case, it's already done. Okay, now the way you deal with equations and greater than and less than differs, right? How do you deal with an absolute value less than like this one? Not to. Okay. Hannah says -2 less than x plus 4 less than 2. What's that called? Just describe it. What is it? It's a 3-part inequality. Right? 3-part inequality. That's how you do absolute value less than. So, I mean, you could see that the possibilities over here, 2 of them, the solution is a 3-part inequality, and 2 of them are not. So, I mean, those are not going to be the answers. Okay. How do you solve the 3-part inequality? Isolate the variable in the middle part by doing operations to all 3 parts. So what is the one operation we have to do here? Subtract 4. And so we're going to get -6 is less than x is less than -2, which is this one. Now, that's a pretty easy problem. They could be much more complicated than that. But we could still use this problem to show how you can do these in the calculator too. And if you haven't seen this before, then here you go. Let me lock. So I'm going to go y equals clear. Now, do any of you have the x equals in the top line? Yeah. If you have x equals on the very top line, like right to the left of where it says plot 1, then, I mean, you can work with it. I mean, yours will come up different. Like yours is going to come up on the equal sign, or there's probably an inequality symbol right there. So you have to like right arrow to get to the right of that, which is, you know, in a way, I kind of don't like having the x equals there, unless I really know that I need it. But the x equals is there because of an app, right? The app is called inequals. If you look at number 6 on most of them, one of them up here is not, but it's in there, right? What number is it? It's 3. So wherever you hit that, if you want to get the inequals off, then you hit enter. Right? You know, it'll give you a menu and you can turn it off. We'll talk about inequals, not this slide, because we don't need it for this slide, but we'll need it for the next one. So for right now, I'm just going to go back to y equals. Oh, look at that. It actually put it there. So now I've got the x equals there, but I don't want it there. So I'm going to go back to apps, back to inequals, quit is number 2, and back to y equals. Okay, so if I want to put in this absolute value inequality here, first I got to bring up absolute value. Where is that? alpha window is one way to get it, right? And then I'm going to put my x plus 4. And then I need to pull the less than symbol. You know where the inequality symbols are? Second math. So second math. And then pick out your inequality symbol. We want a less than, and that looks like number 5. And then I need the 2. Okay. Now, when I graph this, zoom 6, what you see is that wherever this inequality is solved, then the value of the function is 1. And wherever it's not solved, the value of the function is 0. So it's actually right on the x-axis. So what does it look like are the, boundaries there of where it's solved? It looks like from -6 to -2, which is what we've got. Okay. Now you could look in the table of values and try to pull it from there. Right, if I go second graph for the table of values, and you notice that it says for -5, -4, and -3, it's 1. It's not there for -6 or -2. Why not? Yeah, because it's not or equal, right? So it actually does not include -6 and -2. It looks on the graph like it goes all the way up to there, but it actually doesn't include those 2 points. Just notice if I did this, if I went back to y equals, and I turned that less than into a less than or equal to, right, second math, and that would be number 6, right? And now I go back to the graph. The graph is going to look the same. You can't tell the difference from one infinitesimal point, but I go back to the table of values, and now -6 and -2 would be there, because it does include those, because of the or equals to. So, in any case, that is a way you can solve these, even if they're more complicated. Even if there's like isolating to do and things like that, it doesn't matter. You don't have to isolate anything. Just enter it in on that line to the right of the equal sign, and it'll show you the graph, which should be enough for you to figure out which is the right one. Okay, so this is a one variable inequality. Okay, the next one is a two variable inequality. Right, you did two variable inequalities in Algebra 1. The only ones that we're really responsible for are the absolute value inequalities. Right? So, as you could see from these 4, what is the shape of an absolute value function? It's a V, right? So, that part is going to be the same. And that V is going to be transformed by us adding and subtracting inside and outside of the function. That'll determine where the V goes. We have to determine whether we want a solid or a dashed line for the V, right? What is it that makes it solid or dashed? The or equals to, right? This one is or equals to, so they should be solid, and all 4 options are. And then the shading is determined by how? Right? If it's a greater than or equal to, it's above. Right? If it's a less than or equal to, it's below. Okay, so we could tell like right away that the only 2 that have shading above are the A and C. So it cannot be either one of these 2 because the shading's in the wrong place. And this -3 after the function, what is that going to do to the graph? It moves it down 3. Okay, well this one's not moved down 3. So that's it. That's the whole thing. The answer is A. Now, you can do that in the calculator, right? And you could do that in the older version of the calculator too. I could have done it with that. Let me do this just to show. Let me go to y equals, let me clear, and this is how you would do it on this calculator, okay? It's going to be just a tiny bit different for yours. Absolute value, alpha, window, 1. And then I put in my 2x plus 1 and right arrow -3. Okay, and then I would scroll into the left margin, and you can see that cursor is blinking on the left margin. For a greater than, you hit enter once and twice so that it's got that upper right triangle. And now when I hit graph, it draws the V and it puts in the shading. Now you can't tell whether it's greater than or equal to, but everything else you can kind of see. Now on this calculator, now's the point where you use that inequals. So you go to apps, go to inequals, probably at 6, any key to continue, and it pops you up there to the y equals. Of course, it's on the equal sign. So let me do this. Let me go to the right and clear. Let's put in the 2x plus 1 absolute value. 2x plus 1 minus 3. Okay. Now when you scroll to the left, right, eventually it's going to pull up, it's going to have that blinking rectangle on the whole left-hand side. And when I hit enter, it pulls up a little menu. So it's going to give you a blue shading and everything. The line and the shading will be blue. If I arrow down to the next line, I can pick out the inequality symbol. We want greater than or equal to. So make sure you get the greater than or equal to. Then you go arrow down again. You could see that what it says for style. The style is that upper right triangle that we used to get, when we didn't have this inequals. So when you hit down, it skips right over the style. It goes right to the OK. So I hit OK, and it's got the greater than or equal to symbol right in place of the equal sign, and I hit graph. Right, and it draws it in. It does the shading, and it even would do a dashed line if it was not or equal to. And it's very obvious if it's solid or it's dashed. So that is a little bit of an improvement on what we had before. So in any case, that looks like it would be number 1. If sometimes these things don't look exact, you could always, in the calculator, zoom 5 makes it be the same in each direction so that the grid squares are the same. Otherwise, it may not look exactly the same, but now it should be pretty much exactly the same. So how many have used the inequals before? Anybody? Here's another thing about the inequals. So let me clear this. So enter. Let me take that off. Equals. Okay. Okay, and let me clear that. Clear. So you know how you can only graph a horizontal line in the calculator because you don't have an x equals, but that's what that x equals is in the top. If you go all the way to the left of the plot 1, if I hit enter, right now I'm blinking on x equals, and then I hit x equal, it changes all that y equals to x equals. So now I can do a vertical line, right? I can put in the x equals 2. I got to be to the right of that. And then when I hit graph, you see a vertical line. So that's something we couldn't do before. So let's say I had x equals 2, and I wanted to go a y equals 3. Okay, now it's jumped back to the y equals, and I put in the 3. Now when I hit graph, it's got them both. So even though anytime you go to y equals, you're only going to see y equals or x equals. But the one that's not there, the equation's still there. So there's the x equals, it's still there, x equals 2. Now, you might look at that and say, well, that means, can I now solve a system that's got a vertical line part of it? And the answer is no. Like if I tried to find the intersection point, second, trace, 5, enter, it doesn't jump to the vertical line. Enter, enter, it just stops, So, you couldn't use this to solve a system, let's say. But, it's a little bit of an improvement. You can do an x equals. So just, keep in mind the difference between those last two problems. The first one was a 1 variable inequality. You put all of that to the right of the equal sign. This one is a 2 variable inequality. you're going to use the inequals app to get everything just the way you want it. So I'm going to go back to the app and turn that off because I don't like it when I don't want it. So now it's y equals and I don't have the x equals at all. Okay, so that was number 15. 15. Okay, this is number 16. All right, this is solving a quadratic, and it's not in multiple choice format. So what are my options here? What would I have to do in any case? Christian? You got to get everything on one side, right? So x squared plus 4x minus 16 equals 0. Okay, then what are your options? How do you solve a quadratic equation? Factoring, quadratic formula, or we could use that app, right? The Poly SMLT2 thing. Let's do quadratic formula too. Well, first, is it factorable? Are there factors of negative 16 that add up to 4? No, there's not. They're not factorable. So if I was going to use quadratic formula, I would have to say x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 16. All over 2 times 1. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 16 is like 16 plus 64. Remember that this minus here, combines with that minus to make a plus. So that's actually 80 divided by 2. Now, at this point, I could look at the 5 possibilities and say, well, it is not going to be this one, right? It's not plus or minus 4. It's a little more complicated. It's not going to be imaginary, right? Because the square root of 80 is a positive number, so I can knock that out. And honestly, between these two, there's only one little difference between those two answers. And I think you could tell right away which one is correct without having to do anything more. Which one should it be? It's got to be the negative 2, right? This thing right here is telling you it's going to be negative 2. So that's the answer. Okay. Now, if you did that in the calculator with the app, right, I would have to go to, again, apps, 8 for most of you, and then 1 for polynomial root finder. Okay, you want the order to be 2, and let me make that real. Most of them probably are going to come up on real. And then you're going to go next. And let's fill this in. 1, 4, negative 16. 1 plus 4, and I'm going to make that minus 16. And once you got them in there, then in order to access you can't see that, sorry. In order to access the solve, right, that's right there, you hit graph. Now, because we got like irrational numbers here, right, a square root of something that doesn't simplify, you're going to have to compare your numbers to these decimals. But, I mean, you could match those up and get it right. If I simplified this further, well, let's just use theirs right there. Negative 2, trying the calculator, negative 2 plus 2 root 5. And then do negative 2 minus 2 root 5. And see if you don't get those two decimal values. And you will. Okay, but what if this equation was a little bit different? What if it was like this? X squared plus 4x plus 16. Okay, in that case, when I do the b squared minus 4ac, I'm going to get 16 minus 4 times 1 times 16, right? And that's going to be the square root of something that's less than 0. So what kind of answers do you get? Imaginary. Okay, you can do that with this app, right? If you go back to the main and one for polynomial root finder, on the second line, you can set it to do a plus bi. And then go to next. Again, I'm using the same numbers except for that's a plus. And once I'm happy with that, I hit solve. And you can see it gives you, negative 2 plus a decimal times I, negative 2 minus a decimal times I. So that app will solve even imaginary quadratics that have imaginary solutions. Okay, so that's enough of that. Next. This is number 19. This is a problem you might have seen on the Algebra 1 exam. Yeah. Yeah, sure. Absolutely. This is a question you could have gotten on the Algebra 1 SOL. Where if you're just looking at one graph of one function and you want to know where does that function equal 0, where are you looking on the graph? So there's the x-intercepts, right? That's it right there. And so negative 3 and positive 1, the only one of which is in there is the negative 3. So you hit that one. And again, this is not new, but it is kind of like the important part of this is to make sure you understand that the x-intercepts of a graph are the same thing as the zeros of a function, are the same things as the solutions to the equations, are the same thing as the roots. So, no matter how they ask the question, in the end, it's just that same thing. That's why, the easiest thing may be for any kind of function that you get, if it asks for zeros or solutions or roots, you just graph it and look at the x-intercepts. That's got to be the answer. The one place where we get confused on this, where it can be like a reverse sense, is, what if I have to identify a function by its linear factors? How did the linear factor, the zeros, relate to the linear factors that make it up? Right? It kind of has an opposite sense, right? It's x plus 3 and x minus 1. Okay, it's really x minus the 0. But if you do x minus the negative 3, that's like x plus 3 and x minus 1. Now, would that be exactly our graph? Probably not. How could I make this function open down? Right now, if I graph this, would it open down? How could I make it open down? You need a minus in front. So, at that point, you could see whether this is, does that look like exactly our function? Main 6, y equals clear. And negative x minus x plus 3 times x minus 1. Yeah, it looks like that's it. That is the whole thing. Okay, next. Okay, this is number 26. Right. What are the, if one solution to a quadratic equation is 13 minus 11i root 7, then what is another one? Which one of those four would be the other? Okay, this is the part you got to keep in mind, right? It's the word is conjugates. Right? If one conjugate is a solution, the other has to be a solution. What is the conjugate to 13 minus 11i root 7? 13 plus, right? It's just the change the sign in the middle, right, to a plus. So essentially what you're saying is that there's two solutions, and they are 13 plus or minus 11i times the square root of 7. You know, where do these kind of solutions come from? How did you probably calculate them? Quadratic formula, right? And that quadratic formula, because it's got the plus or minus there, means you can never just get one of those. You got to get the pair. Right? You got to get the pair. The same thing would be true if they had asked the question, the solution to the quadratic equation is 13 minus 11 times the square root of 7, no I involved. You'd still have to say then it still has to have plus or minus. Because you don't get that square root of 7 except for you got it from the quadratic formula. So there's got to be a plus or minus in front of it. So it's not just complex conjugates, but also, let's say, irrational conjugates. Okay, so either one of those. And you know, this is a knowledge question. This is just something you got to know. And if you know it, you know, it's like a half a second. Okay, bingo, move on. Right, and you should know it. It should be an easy question for us. Okay, then number 50. So number 50 is a quadratic equation. They're using the word roots again. Okay, so again, we just think of that as x-intercepts, solutions, zeros, all those things. And they're not asking you for the solutions. They want you to describe the solutions. Right? This gets back to something that we did at the end of using quadratic formula. It's using the discriminant, which is only part of the quadratic formula, to determine the number and type of solutions. Right? So if you remember, the discriminant is which part of the quadratic formula? It's just the b squared minus 4ac. Right? It doesn't include the radical or anything else, just the b squared minus 4ac. Now we know that occurs underneath a radical. So what we learned is if the discriminant, I'll call d, is greater than 0, then you're taking the square root of a number which will have real solutions. Right? The square root of a real number, positive real number, are positive real numbers. Okay, so you would have two real solutions. Okay, if the discriminant is less than 0, now you're taking the square root of a negative number. Right? So what kind of solutions? They're imaginary, and there's 2, right? That's why imaginary zeros always occur in pairs. So 2 imaginary. And if d equals 0, right, then you're taking the square root of 0, which is 0, right? And plus or minus 0 gives you the same thing. So you only get one real solution. So if I use that, then I would have to get everything on one side, 0 on the other, 9x squared minus 6x plus 1 equals 0. And then I'll do my b squared minus 4ac, right? That'll be negative 6 squared minus 4 times 9 times 1. What does that equal? It's 0, right? So that's this one right here. So the answer is 1 real root. Now, how else could you have done that? What do you mean in the calculator? Yeah, just graph it, right? So let's see what it looks like if I would graph 9x squared minus 6x plus 1. Right? And I hit the graph, and I'm not up there. And you can see it looks like it touches the x-axis in one place. That's the one real solution. Okay, what would it look like if there was 2 real solutions? 2 x-intercepts. So like if I go here and let's change that plus 1 to a minus 1, then I hit graph. It's going to take it down below the axis. Now you've got 2 real solutions. Okay, what would it look like if there's no real solution? It never crosses the axis. So like I would put in, what if I put in plus 1? How about plus 3? Graph. That's what it looks like if there's 2 imaginary solutions. You know, it just never crosses the x-axis. I mean, we know there's going to be 2 solutions, right? Because that's the fundamental theorem of algebra. You have exactly as many complex zeros as the degree. So we have to have 2. Right? The fact that we see no real solutions means there's 2 imaginary. That's how it works. Alrighty. And that is all I really, no, is it? There may be, I think that is. So it just adds 2 more pages to that review package to work on. So you want to write those down for a second? Yes. Pretty much. Yeah. So 14 is 1 through 7, and 17 is 1 through 6. So you should try to finish these in class today, right? Don't let it wait. The other thing I was going to show you is, and for you guys, you probably, most of you know how many of you used JLabs before? The JLabs? They're pretty good for Algebra 2. I mean, you know how to go there, right? I mean, just Google JLab. The very first option says JLab SOL quiz, right? And it looks like that when you get there. So you just have to pick out Algebra 2, however many questions you want. You can say just get ready, just get started. I mean, at this point, you know, if you go through the next options, it offers you the chance either to use the released questions from Virginia Department of Education or other questions that have been developed by these school divisions. You know, I've done that, and there's only 2011. It's like they did this is a great idea 6 years ago, but nobody ever followed up with it, and that's all that's there. You could pick one or both, right? One or both. When it says use realigned strands or use original strands, that has to do with the SOLs changed in 2009. So if you use the original strands, then depending what years you pick, you could get some questions that we actually don't do anymore. So it's probably safer to use the realigned strands. Okay, all years. Let's just say we pick all years. You know, at this point, we've done most of expressions and operations and equations and inequalities, but we haven't talked much about the functions and statistics. That's what we're going to do in the next couple. And then you get to, you know, pick what you want. So let's say I pick the fixed set number 1. It's going to be 20 questions. You know, if you click on one, let's say I click on it and I get it wrong, right? Then it'll tell you the right answer, and you can click read explanation, and it'll explain down below what you should have done. So these are pretty good. So with that, I will leave you to this, and when I see that most people look like you're done, I'll put up the answers and we can go through that. Okay.